I'm going to show you how to use the Excel Companion Significance Testing Workbook to test hypotheses about a sample mean. I'm assuming that you already understand a few essential concepts. I'm assuming that you know how to describe and compare interval level data with means. I'm also assuming that you understand the foundations of inferential statistics, especially the null hypothesis significance testing framework. This video is for people who already know what significance tests for means are and now want to learn how to conduct these hypothesis tests with Excel. It's easy to test a hypothesis about one sample mean with the Excel Companion Significance Testing Workbook. You can download this workbook from the Excel Companion's website. You just input a few values specific to the problem you're trying to solve. The worksheet does the calculations and shows you the results. To test a hypothesis about one sample mean, you input 7 values into our worksheet. 1. The hypothesized value. 2. The hypothesis direction. 3. Alpha, which is your type 1 error rate. 4. The sample mean. 5. The sample size. 6. Your assumption about standard deviation. And 7. The standard deviation. This may sound like a lot to input, but you'll see that it's not too hard. The values you input should be given in the problem you're working on. After you enter this information, the worksheet shows you the p-value for the null hypothesis test, reports the conclusion, and shows you how it calculated test statistics. To see how it's done, let's work through a couple of examples. Okay, we've got an example here of a one sample difference of means test. This is a situation where you're given or you calculate a sample mean and you want to compare that sample mean to a hypothesized sample mean and determine if it's significantly bigger, significantly smaller, or significantly different than the hypothesized value. So looking at one example here, and this features a known standard deviation. So there's really two flavors of this test. One with a known population standard deviation, fairly rare, that will calculate a z-statistic, as we'll see. And this is what this example is, a known standard deviation. And to kind of preview the other example, that has a unknown standard deviation, and the standard deviation so it is estimated from the sample. And to do this example, I will use the one sample difference of means test worksheet. And this example reads, 1,393 college seniors took a standardized civics exam. Their mean score was 71.8. The exam has a known standard deviation of 10. Was their mean score significantly higher than the civic literacy benchmark of 70? Let's look at our worksheet here. We'll start with inputting the hypothesized mean value. The problem says there is a civic literacy benchmark of 70, so that's the hypothesized value. We are testing whether their mean score was significantly higher than the civic literacy benchmark of 70. So we are testing this middle hypothesis that the mean is greater than the hypothesized value. Alpha not specified in the problem, but let's assume that it's 0.05, the conventional level for significance testing. The sample mean supplied by the problem is 70.8, so we will input that, and the sample size is given to us in the problem, 1,393 students. Now this is the part of the worksheet I was kind of foreshadowing. Population standard deviation known. Yes is checked, and that's appropriate because the problem says the exam has a known standard deviation of 10. So I can check yes that it's known, and the population standard deviation, enter it, is 10. Now it's going to report our results. It says that the p-value is 0.000, and kind of has this note to the side. Report p-value as less than 0.001, because it can't be 0, but it is less than 0.001. That's a very small value, so we reject the null hypothesis because the p-value less than 0.001 is less than the alpha value of 0.05. And what we might look at for the internal calculations, is this is comparing the test statistic, which is a z-score of 6.718, to a standard normal distribution to obtain the p-value. So the p-value comes from this cell. The standard normal value is the upper tail of a standard normal distribution. There is less than 0.001 of the distribution above 6.718, because that is we are very unlikely to obtain this test statistic by random chance. We would reject the null hypothesis because the data showed that the students' mean score was significantly higher than the civic literacy benchmark of 70. Another example of a one sample means test with the significance testing workbook. Now this example is going to feature an unknown standard deviation. The inputs in the worksheet are going to be pretty similar to the last example, but the assumption of unknown standard deviation and that the standard deviation is estimated from the problem changes the test statistic and changes the test. The worksheet's going to handle a lot of that automatically for us, but I want to point it out as I discuss the problem. So let's read this. Students were asked to assess their college president on a 0 to 100 scale. 0 is very cold, 50 is neutral, and 100 is very warm. Sounds like a standard feeling thermometer test of the college president. It says the mean is 53.9 and 236 students, and the standard deviation 13.6. So this standard deviation comes from the sample itself. It's not known in the population, it has to be estimated with the student sample, and the estimate of the standard deviation of the scores 13.6. And we're asked to test the sample mean against the hypothesized value of 50. And the problem doesn't say test that it's greater than or less than, so we're just testing whether it's different than 50. So whether the students have a not neutral feeling about the college president. So the worksheet values, let's start with the hypothesized mean value given to us in the problem, 50. For the research hypothesis, we're testing whether the mean is simply different than 50. So I will click the two-tailed version. And you can kind of see here that the mean is not equal to 50. And we would reject that null hypothesis if it's either significantly greater than 50 or significantly less than 50. Alpha will leave at the conventional 0.05 level. The sample mean for the problem, 53.9. Sample size from the problem, 236 students. Now, the next input is population standard deviation known. I'm going to uncheck it, uncheck yes, because the population standard deviation is not known. It has to be estimated from the sample. So it asks me to input the sample standard deviation. The problem says it's 13.6. Let's finish up my inputs. Now this is telling me that the p-value is 0.000, and of course we've got the same note here that we should report that is less than 0.001. And because that p-value is less than alpha, we would reject the null hypothesis. So the students have a mean assessment of their president that is significantly different than neutral. In this case, it's significantly greater than 50. Now look at this, the internal calculations again. What happened when we unchecked known population standard deviation? It changed the relevant distribution that the test statistic is compared to. Rather than comparing it to a standard normal, it's now comparing it to a t-distribution with 235 degrees of freedom. So one less degree of freedom than the sample size. So if we compare the test statistic 4.405 to a t-distribution with 235 degrees of freedom, we'll find that the two-tailed value is less than 0.001. So there's very little density in a t-distribution with 235 degrees of freedom, greater than 4.405 or less than minus 4.405. And because this means test with a estimated standard deviation uses a t distribution for comparison purposes, this test is often called a t-test. Most uh, sample means test, significance testing with sample means, uses a t-test statistic, and so it's called traditionally called a t-test. But as you saw from the prior example, if the population standard deviation is known, you get a z statistic compared to a standard normal distribution. But this example, the unknown standard deviation is more common. So the most common situation with a one sample means test uses a t statistic compared to a t distribution. Because we got t statistic, t distribution, it's called a t-test. And in this particular example, the t-test has a statistically significant test statistic, has a very low p-value, and so we would reject the null hypothesis.